Welcome to VJD Academy. This is Anil Kumar, Faculty of Digital Electronics. Up to now, we have seen few types of combinational circuits, and the leftover concept in combinational circuits are special types of adders. We have seen half adder, full adder, half subtractor and full subtractor. Apart from that, we have three leftover concepts. We can say that serial adder, parallel adder and carry look ahead adder. We can say these three are the special types of adders. And now let us try to understand what are those three and how they work and how they add and subtract the values. Let us see. Just make a heading. Adders, special adders. So basically these are the three types. We can say special adders. All these are combinational circuits first. Combinational circuits. And now second thing we can say these are three types. These are three types. These are three types of circuits. First one, just make these points. The first one is, we can say serial adder. Serial adder. The first one is serial adder. And the second one is, we can say parallel adder. Parallel adder. Sir, we can also call this parallel adder is ripple carry adder. Ripple carry adder. We will understand why we are calling this ripple carry adder. How it is carrying a ripple to the next flip-flop. We can say next full adder. We will see. We are going to see that. And now the third one is very, very important. Carry look ahead adder. These are the three types of adders. Sir, let us try to understand the analysis and we will see few problems based upon these three types of adders. The one thing that I want to convince here is, here these three are the combinational circuits. First thing. The moment when I thought a combinational circuit, we have seen the few principles. Combinational circuit output must be depends on its present input. And combinational circuit should not have any kind of memory. And combinational circuit should not have any kind of feedback. And combinational circuit should not operate by any clock signal, clock input we can say. So these are the basic principles of a combinational circuits. Sir, but apart from all those things, even though these three are serial adder, parallel adder and carry look ahead adder, these three are the combinational circuit for sure. But these three are the circuits which are having a feedback. And the output again we are connecting as a input. These three are working along with the feedback. And now even then we are calling these circuits are combinational circuits. You may ask me, sir, if a circuit is having a feedback, you must be able to call that circuit as a sequential circuit instead of combinational, as you said. Yes, sir. But the one thing, the main difference between sequential circuit and combinational circuit is, if the present output depends on its present input, then we must call it as a combinational circuit. Suppose if the present output depends upon its present input and also its future, or we can say past input. If the present output depends on its present input and past output, we can say that those kind of circuits are sequential circuits. This is a circuit, serial adder, parallel adder and carry look ahead adder. These are the three types of circuits. Its outputs depends on its present inputs, and these outputs does not depends on its past outputs. Of course, these are having a feedback. Let me explain a clear manner. You will understand. You will say that, you will convince that finally these three are the combinational circuits. We can say these are the special types of adders. That is the reason I didn't teach all these three types of adders while we are learning about off adder and full adder and something else. At the end of the combinational circuits, I am teaching these three types of adders. We will try to understand. You may get one question from at the end, how many number of full adders, how many number of other adders, how many number of gates are required to implement these types of adders, and what is the delay required to complete one complete addition. That kind of questions may be asked based upon these three adders. Let us try to understand. Just make a note of it. And now let me take the first adder, serial adder here. Just make a heading. First make a heading, serial adder. Serial adder, and write a few points here. Serial adder. The first thing, sir, serial adder, first point is it is a combinational circuit. It is a combinational circuit. And now this circuit, it consists of two inputs and two outputs. What are the two inputs? We can say inputs are two. We can say A comma B are the two inputs, and outputs we can say these are the adders. So now it may get sum and carry. Outputs are, we can say, two, which are sum and carry are the outputs. And now if you look at the block diagram, the third one, we can say block diagram of serial adder. If you ask me, let us try to understand here. This is the serial adder. This is the serial adder. What are the inputs are here? Sir, I want to say that these are the two inputs. One is A and another is B. Here the outputs are, we can say first output is sum and the second output we can say carry. Second output is carry. Sir, here whatever the carry output is there, here the carry output we will try to take back. And we will give here some delay, and finally it will come and apply to the serial adder. This is called feedback, we can say that. Sir, here if you ask me, there are some kind of register. It is used to store one bit. It is not a resistor. Resistor is used to restrict the flow of electrons. The term we will use in electronics and devices circuits. But here we are using resistor. We can say resistor. It is used to store one bit. Are you following? Are you with me? Say yes or no. Yes. Now here we have two types of resistors we will use. What is the purpose of resistor, sir? I said just a little bit earlier. It is used to store one bit element. This is a resistor. We can say that input A. And now this is also one more resistor. We can say that this is also one more resistor, and this is B. So now what I am trying to do here, just I want to apply few inputs. Let me take here 1 0 1 1, here 1 1 0 1. These are the inputs that I want to apply. For these two inputs, when I apply, automatically the first bit is here, we can say this is what LSB bit, and this is what MSB bit. Here this is LSB bit and this is MSB bit. And now this serial adder, first of all it will collect the first LSB bit here 1 and here also 1, and now it is trying to add 1 plus 1, A equal to 1 and then B equal to 1. Here the first it will take A equal to 1 and B equal to 1, and now it will try to add A plus B. Automatically we know that when we add 1 plus 1, here the output is, we can say, 0, and there is a carry, that is called, the carry will be 1. That is what we have learned when we add, addition, full adder, subtractor, even. So here the carry is 1, and now this carry will come here, and now this carry will store here, delay, and after some delay, how much delay, sir? Here the first addition is done, and now this will be removed, and the next addition will be, we can say that the next consecutive inputs are here, this is A equal to 1, and then this second bit is, we can say, 0. So now this, the moment when we add A is 1 and then B equal to 0, the moment when we are trying to add these two things, automatically this carry bit will come. The carry, previous output carry is here, we can say 1, and now this 1 will store here up to what extent, sir? Up to the next bit. We can say that the second bit comes unto available for the addition. For that particular delay we will store this carry bit here, and now we will make this carry bit available here. We can say that this is called C equal to 1. So that is the thing. Sir, you please try to understand one point here is, in first addition, we are just making addition of 2 bits. We can say A equal to and B equal to. We are just using 2 letters. So to make addition for 2 bits, we are using just half adder. And coming to the second addition, we can say that the carry we are applying as an input, and now for the second input, here A equal to 1, B equal to 0, and then C equal to 1, which means for 2 inputs half adder we are using, and now for 3 inputs we need to use full adder. So this is the important thing. How many number of full adders, how many number of half adders we are using to implement a serial adder? That may be the question. So to implement one serial adder addition, we may be using n full adders and 1 half adder. We can say we are using one half adder we are using, and all other are full adders, we can say. So now here A equal to 0, B equal to A equal to 1, B equal to 0, and then C equal to 1. So that here this addition may go. The moment when we apply here, the carry feedback is here. Now A equal to 1, B equal to 0, C equal to 1. And can you please just tell me, here A equal to 1 and now B equal to 0. The addition will be, we can say, 1. Output is 0. There is no carry here. And now let us try to add C to this output. Here C equal to, we can say, the previous carry is 1. We can say here this is previous carry. And now let us try to add these 2 bits. What will happen? The addition output is 0. We can say this is sum output. And now what is the carry here? There is a carry remains. We can say carry. So now this carry I want to give here. This carry I want to give here, so that this is the carry. And now this carry will come to here for this delay. Here again carry is 1, and now we will apply C is 1. And now, sir, the third addition, we can say that here 0 will goes. What is the third bit for this shift register? Here the shift register is shifting the 0 to this place, and now here 0 to here. We can say that is the reason we are calling it as shift register, or we can say register. It is used to store 1 bit, and now to make this operation for right shift, we are using right shift register. We will see what is right shift register, left shift register, and now serial register, parallel register, when we are learning about a 4th unit called counters and registers in sequential circuits concept. Now, as of now, just try to understand, this is a register and it is used to store the 1 bit, and it is used to shift the bit to right. Here 0 will comes here. So automatically this one is disappears, and now this one is also disappears. 0 comes here, and again 0 comes here. Here there is no 0, and now this 1 will came here because the 2 bits are shifted. Here these 2 now empty. Here sir, again we can say that this is 1 and now this is 1. Here these 2 bits are empty. Now here A equal to 0, B equal to 1 we can say that. And now again addition operation performs. Here if you see the second addition operation, here A equal to 0 and now B equal to, we can say 1, and now again C equal to 1. Here what is the addition? 0 plus 1 we can say 1. Here 1, and now there is no carry, and now 1 plus 1 we can say 0 and 1 is carry. Again here some output, here again 0 and now again carry is 1. Here this carry will goes here, and now again we will apply the final output. We can say here again this 1 will shift here, 1 1. Here A equal to 1 and now B equal to 1 again, and now here carry is 1. Now there is a addition. This is the process how we can do a serial addition. Sir, can you please just tell me to make, when we apply here, we just applied A is 1 bit and B is 1 bit. Here for A 4 bits we applied and B 4 bits we applied. To make this addition, how many number of full adders are required, sir? 3 full adders and 1 half adder. We have seen. And now to make this addition, how much delay we are taking, sir? We are taking for 1 bit addition. When we are adding these first 2 bits, we need to wait for completion of the first bit addition result. And after completion of first bit addition, then only this shift register is used to shift to right, so that these inputs, second inputs we will add. Sir, to make n bit addition, how much delay we require, sir? To make n bit addition, we need n minus 1 bit delay, TPD, time propagation time delay. So that is the disadvantage of the serial adder. When we make, here please try to note it down. Please try to note few drawbacks of the serial adder. Here first point, to make addition we need 3 full adders and 1 we can say half adder. And next thing we can say, to make 4 bit addition, we need 4 TPD delay. And now to make n bit addition, here 3 TPD, n bit addition, we need n minus 1 TPD delay. Sir, this is a lengthy process, we can say, time consuming process. This is what a very huge disadvantage in serial adder. If you want to add more number of bits at a time, and even it cannot able to add at a time 4 bit, 5 bit, 6 bit at a time, it cannot able to add. It can add only 2 bits. It can subtract only 2 bits at a time. So that is the disadvantage in this serial adder. If you want to achieve this delay, and if you want to increase the speed of addition, we just need to forward for the next adder called, we can say, parallel adder. Just to make a heading, parallel adder. In parallel adder, we are applying 4 bits at a time, and then we are increasing the addition number of inputs also, and now we are decreasing the circuit length and the hardware required, we will see, and now we will try to increase the speed of the addition. To increase the speed of the addition, we are just moving forward to parallel adder. In serial adder, we have a less number of additions are possible at a time, and now less number of bits we can able to add at a time. And second thing, we need shift registers and delay block and even full adders and half adders to make addition. And also we have a particular huge delay to add every addition. So to overcome this, we are moving forward to parallel adder. In parallel adder, we will apply inputs parallelly, so that instead of serially, we will apply parallelly, so that output will be possible to get instantly. Thanks for watching. Please do subscribe.